We want to find the partial fraction decomposition of the given rational expression, which means we want to write the given rational expression as a sum or difference of simpler rational expressions. The first step is to make sure the denominator is in factored form, and because our denominator has 4 terms, let's try to factor by grouping. So if we want to factor x to the third plus 2x squared plus 9x plus 18 by grouping, we factor out the greatest common factor from the first 2 terms, then the greatest common factor from the last 2 terms, and then hopefully we have a common binomial factor. So the greatest common factor of the first 2 terms would be x squared. So we'd have x squared times the quantity x plus 2. Notice that 9 is the greatest common factor of the last 2 terms. Because we're factoring out a positive 9, we'll write plus 9 times the quantity x plus 2. And notice how these two products do have a common binomial factor of x plus 2. If we factor the x plus 2 out, notice how we'd be left with x squared plus 9. And now we have the factored form of our denominator. So the given rational expression is equivalent to the same numerator. And now the denominator in factored form would be the quantity x plus 2 times the quantity x squared plus 9. So notice how we have a linear factor and a quadratic factor, which help us determine the partial fraction decomposition. Again, the given rational expression with the factored denominator would be equal to the sum of 2 rational expressions, where the first denominator would be the linear factor of x plus 2, and the second fraction would have a denominator of x squared plus 9. And now for the fraction with a linear denominator, the numerator would be a constant, which we'll call a. And now for the second rational expression here that has a degree 2 denominator, or a quadratic denominator, we would have a linear numerator in the form of bx plus c. Now the next step will be to clear the fractions from our equation, which will give us what's called the principal equation. So we'll multiply both sides of the equation by the least common denominator, which would be these 2 factors. Notice the left side of the equation simplifies nicely to 7x squared plus 11x plus 46. And on the right side, for this first product, notice how the factor of x plus 2 simplifies out or divides out, leaving us with a times the quantity x squared plus 9. And for the second product here, the factor of x squared plus 9 simplifies out, leaving us with plus the quantity bx plus c times the quantity x plus 2. And now to find the values of a, b, and c, we'll equate the coefficients. So for the next step, we'll multiply out the right side. So we'd have ax squared plus 9a plus bx squared plus 2bx plus cx plus 2c. Now we'll group the x squared terms together, the x terms, and the constants. So we have ax squared plus bx squared, and then we have 2 x terms. We have plus 2bx plus cx, and the constant terms would be 9a and 2c. So plus 9a plus 2c. Now let's factor the x squared out of these 2 terms, the x out of these 2 terms, and then we'll just group the constants together. So let's go ahead and put the x squared factor on the right. So we'd have the quantity a plus b times x squared plus, let's go ahead and factor out the x and put the factor of x on the right. So we would have 2b plus c, and then we just have plus the quantity 9a plus 2c. And now we equate the coefficients to form a system of equations, meaning the coefficients of the x squared terms must be the same. So 7 must equal a plus b. 11 must be equal to 2b plus c. And finally, 46 must equal 9a plus 2c. So again, we can say that a plus b must equal 7, 2b plus c must equal 11, and 9a plus 2c must equal 46. So now I'll have to solve this system of equations to find the value of a, b, and c. Let's go and do this on the next slide. Let's use elimination and eliminate b from these first two equations. So notice how if this was negative 2b, we could add the two equations together to eliminate the b term. So let's go ahead and multiply this first equation by negative 2, and we'll leave the second equation the same. I'm going to go ahead and put the b term first, so we can write this as negative 2b minus 2a would be equal to negative 14. And the second equation stays the same. We have 2b plus c equals 11. So notice how this gives us an equation that contains a and c, and then we can use a third equation to solve for a and c. So here we have negative 2a plus c equals negative 3. So now we'll use a third equation, 9a plus 2c equals 46, and this equation that we just formed, negative 2a plus c equals negative 3, and we'll solve this system for a and c. And then we'll perform back substitution to find b. To eliminate c, we would want this term here to be a negative 2c, so we'll multiply the second equation by negative 2 and leave the first equation the same. So 9a plus 2c equals 46. Here we'd have 4a minus 2c equals positive 6. So the c's simplify out. We have 13a equals 52. Dividing both sides by 13, notice we found that a equals 4. So a equals 4. And I'll perform back substitution to find b and c. Well, notice here, if a is 4, we know a plus b is 7, so b has to be 3. And if b is 3, 2 times b would be 6. 6 plus 5 is 11, so c equals 5. These are the values that we needed to find the partial fraction decomposition. We'll now substitute a, b, and c here, here, and here, and this will be our partial fraction decomposition. The partial fraction decomposition of the given rational expression, because a is 4, would be 4 divided by the quantity x plus 2, plus, because b is 3 and c is 5, we'd have 3x plus 5 divided by the quantity x squared plus 9. This is our partial fraction decomposition. I hope you found this helpful.